Good evening, Professor. Today I will be discussing about the programming assignment 1. So let's get into that problem. So in this problem we are supposed to solve a map coloring problem, which is a common problem in graph theory. So for this problem we are used to solve the map coloring problem for the map of Canada, in which no two neighboring states which share a border should have the same color. So to solve this problem, I've taken the graph of the map of Canada and represented it in an adjacency matrix, in which, if for example this is the array of arrays and the array at the 0th index represents Alberta, and if it shares a border with the state which is represented at the ith border, then it is 1. So for example, at first index, there is British Columbia and Alberta shares a border with it, so that's why it's represented 1. And similarly, it shares a border with Manitoba, which is at second index, so it is represented at 1 as 1. And this is what is given, and we take the input as number of colors, maximum number of colors that can be used from the user, and we provide the output with the names of the states, names of the province, as well as the color assigned to them. So let's show you how the program works. So if we run Python file in terminal, so here it is asking us to for a number of maximum number of colors that can be used. So we know that for this problem the minimum number of colors required are 3. So what happens if we enter less than 3? So as you can see, it is showing that the solution does not exist. Now let's give the answer, the input 3. Here you can see it is giving us the color for each of the province, and as you can see, the no two provinces which share a border have same color. So now let's look at the code. So this is the main part of the solution. We are using a backtracking algorithm. So first we are initializing the color array, and which would be equal to the length of the graph. For us that will be 12, and each index for that 12 indexes will be initialized with 0. And if the graph coloring util functions, which is the recursive function, which is the main meat of this algorithm, of this program, returns false, then there is no solution that exists for these much number of colors. Let's now look at this function, graph coloring util. This is just a way to end the program to return if the node is out of bounds. As you know, the node should always be less than length of the graph. So if it is equal to, so that means it is out of bounds, and we turn the program and return the function. This is the main part of the function. In this, the C is starting from 1 and going until the nums colors. You might ask why plus 1. That is because in Python the range the second variable is not included. That's why we have to go till plus 1. So this will be 1 2 3 for the input 3. And then is save function checks that if the graph node, for the case of Alberta, that will be for 0 0, is there 1? No, there is not 1, so it will not return false, it will return true. That means it doesn't share a border. But for uh, 0 1, it will be 1, and there might be a case in which the color is also same, so that it will return false. and then you will have to go to the next color. As you can see, this also iterates over the colors. But here is the main backtracking part of the program. The in this we are again calling recursively the graph color util function, but this time with node plus one value. But if this function does not returns true, which means that it is false, then we will change the current node value to 0, and the for loop will work again, and this time it will give some other value, because we are backtracking to the current position, because the node plus 1 is a dead end, and there is we have to backtrack to find a solution. So that is the way this function works, the backtracking algorithm works. And the if we do the analysis of this algorithm, it is not a very efficient algorithm. For this, the n being the number of provinces and territories, and k being the number of colors, the time complexity for this algorithm is O then k raised to the power of n. But that is just a worst case scenario. In real life situations, we won't be having a kind of scenario in which every province is connected with each other. So in real life scenarios, backtracking algorithms are not so bad. As you can see in our solution, although which is limited, it works pretty well. So that is my submission for this programming assignment 1.